So let's talk about how to make this from there. So this is a molecule that you need to create having a triple bond there. And then, as I said, one of the ways to make a triple bond containing molecule is starting from the simple one, like acetylene. There's a smallest molecule with triple bond. We'll get 2 quarters there. And then we take the protons off and then adding alkyne chain. So what alkyne chain we need to add? We're going to add the methyl groups, and then we need to add the butyl, isobutyl groups. So if you're adding isobutyl groups, methyl groups, we can make that. But there are some things that you need to think about. So that's what let's talk about. Well, how to take the protons away from the triple bonded carbon? If it has hydrogen, you have to use a strong base, not oxygen based. You gotta use a nitrogen based base, sodium amide, because our methoxide, ketoxide, the oxyanion is not strong enough. It's going to be nitrogen negatively charged. So if you use sodium amide, you take these protons away, you're going to make acetylene anion, triple bond negatively charged. Then we need to add the alkyl group as an alkyl halide. Well, use the methyl groups there. So if you're using a methyl bromide, this is just nothing but a SN2 reaction. That makes an attack, take the bromines out, so you can make the left part. Now we need to install isobutyl groups on the right side. We're going to repeat the same thing. We have to take these protons away, so you have to apply the sodium amide again. You're going to make the carbon anion, triple bond negatively charge it. Now we need to add this part as an alkyl groups, which is an isobutyl chloride, isobutyl bromide. If you're using isobutyl tosylate, that's fine. Anything. It's gonna make an attack SN2 reaction. Yes, you can make that. Simple. So why am I discussing this? Well, first of all, it's our first question. Second, we are adding 2 things. We are adding methyl groups. We are adding isobutyl groups. Which order do you have to do it, or does it matter? Right? I mean, I added methyl group first, and then isobutyl groups later. But can we do it the other way? Right? That's the question. Well, let's try to think about what we're going to happen if you do the other way. If using sodium amide, and then you're treating the isobutyl bromide, then you're going to be the alternating that part. Then take the protons away by the sodium amide. Then treat the methyl bromide, then you're going to make the alternation on the left side. So I would say, doesn't matter which one you add first, you can make the product, as long as you do it sequentially in the right way. This is the kind of the things I show you here. So it looks like it really doesn't matter which one comes first. You can make one's on the left first, or one's on the right first. Choices probably doesn't really matter. Let's talk about this one. This is a question I really want you to be careful. A lot of people made wrong for this one. You want to make this from that. So you can think about previous example we just saw. Sure, we can make a acetylene ion, the triple bond negatively charge it, and then make an SN2 reaction, adding part by part at both ends, and then we're going to get the product, same approach. So you can think about, sure, that's the one of the carbon chain that we're going to add. There's another carbon chain we're going to add. So this is nothing different. So you treat the sodium amide, make the proton taken away, and then add in the methyl bromide, then we can put the methyl groups there. I don't see any problem there. That's good. Now we need to install this one. So same thing. We take the protons away from the by using same strong base, sodium amide, making a triple bond negatively charge it, and then alkyl halide that we see from the left side. So this makes an attack, kick the bromines out, and we can make that. What's wrong with that? It's simple, the same as before. And I'm going to say, no, it's not going to go. It is not going to go. Not the reason you think of. I mean, of course, you kind of remember that this is an SN2 reaction with a Burkini compound. So primary alkyl is good. Secondary is not good. You may think that way. That's the reason why this doesn't go, because this is kind of a secondary alkyl. If you count the weight groups there, there's even a little bit more than secondary, but at least it's kind of a secondary hindered. Maybe that's the reason this doesn't go. Well, it doesn't go, but not that reason. Why it doesn't go? Because that reagent only exists in paper. You cannot get that reagent. Let's say somehow you are so clever, make the reagent possible. What happens is this long production comes in, make a double bond, and keep the bromide almost immediately. You never get that reagent. On paper, so many things possible. I mean, sure, going to Mars is possible. I mean, the time travel is possible. So don't think that as long as you write it down, it's going to happen as you wish. Yeah, well, I wish we could live in a world like that, but the thing, unfortunately, yeah, it has to be based on reality. That it doesn't go because of these reagents are impossible to get. That does not mean that we cannot make it happen. You have to find other way to make it happen. That's the reason you have to remember that this acetylenedione can make an attack to the carbonyl. That's the part I've been telling you so many times. You gotta recognize this, especially the carbon bearing the OH groups at the same time. That is actually being made by the acetylenedione, make a nucleophilic attack of the carbonyl. That's kind of what makes it leave behind in the structures. So if you adding a ketone, having a methyl and ethyl groups, so methyl ethyl ketones, then this makes an attack, then you let the pi electron oxygen, it makes an oxygen anion, which get protonated in the end, then you make this. So you have to make it different way. So this is something that you have to recognize. So that's the first thing I want to tell you using this example. But things are not stopping there, because if you think about the previous reactions, the order of doing thing didn't matter. You can add this one first, we can add that one later, or what about we do this one first and then that one later? Should it make a difference? Previous example didn't make any differences, because it means that this one also we can add in any way, any order. So let's talk about that. Now you know, treating the sodium amide will take the protons away, and if you're adding that to the ketone, it will make these reactions. So you can have a right side, I mean left side. This one basically just put it there. Now we're going to treat the base, take this proton, and then put the methyl bromide, and then put the second one there. That's basically will complete the molecule. Only thing I did this reaction first, then the next one. Sure, again, this looks like it can happen, but this is not happening. So why is that? Why this one doesn't happen? It happened before, but why it doesn't go? So this is something that now is questions getting more complicated. You have to think about a lot of other things. You're taking the protons away from the molecule, and then you wish to take these protons away, right? But the problem is, the pK value of these ones is 25, and the pK value of the hydroxy is 610. This is a more acidic hydrogen than that one. So if you treat the base, which proton will go up first? That proton is going up first before that one. So you're actually making a carboxyl one. Then when you're adding a methyl bromide there, it's actually the oxygen is getting methylated, not there. So order can be better. It depends on which question you're solving. Sometimes it may not, sometimes it does. So you need to be reacting two things. Then think about how you're going to carry out. That can make a difference too. So if you do it in the reverse order, you are making different products, not the same one. I mean, all the reagents are the same. You sodium amide and the ketones, sodium amide and the methyl bromide. You just change the order of the reactions, but it makes a different products. So now things are getting a little bit more complicated. More things to think about. So that's not the right product. So I hope that you choose the right way. That is kind of message that I have to give you.